And we're now recording. Okay, so we're almost done, folks. Just quickly review the calendar. Again. So here we are. We're in 13.4 on the rational root theorem, and I already stuck in a little bit of it, so that just makes it a little bit easier for me today. Okay, so I'll finish 13.4, and maybe I'll sneak in a little bit of 13.5, our last section also. I still have Wednesday to do that. I still have Thursday to do it. Okay, Thursday will be your last quiz. And if you have any questions about the test coming up on Monday, you can bring it up on Thursday. So most likely, I'm aiming to finish almost everything from 13.5 tomorrow. So Thursday, a little bit of 13.5, then let you ask questions about the test, then give you your last quiz. Okay, so Monday the 17th, start again with questions and answers as we normally do. Normally, I would start off with a new section, but in this case, there is no new section. So when we start Monday, right away at 11:10, let you ask questions. And when that stops, we break and go straight to the test. Okay, then the rest of the time we'll review for the final. Most likely I'll do something like 2 of the previous exams every day. So we'll have 6 tests total, right? So I'll go over exam 6 on Tuesday, the 18th, and maybe go back and do the first test and then 2 and 3 here and 4 and 5 here, and then we're done. Okay, and our final exam again is Monday the 24th from 11:10 to 1:40. Okay, and to study, just study the old exams. You don't have to go back and study quote unquote everything. On Monday the 17th, you do have the homework requirement as usual, right? So you submit 11.1 through 13.5. Most likely I'll ask about 10 questions. There were 9 sections, so 1 question per section is likely. Okay, there's no homework to turn in for the final exam. Final exam, you just take the final exam and that's it. You don't have to turn any homework. Okay, so plan on maybe about 20 questions for the final exam. Okay, now we're gonna have 6 tests, of which you've already had 5. So 6, most likely scenarios, I pick 3 questions from every test. 6 times 3 is 18, and maybe 2 more from somewhere else. That's not a promise, that's what I'm aiming toward right now in terms of the final exam. Okay, so I'll review the previous exams on Tuesday the 18th, Wednesday the 19th, and Thursday the 20th. Okay, and then we're done with the course. All right, so again, today, I gave you the background for the rational root theorem, and now we're going to do some rational root theorems and hopefully sneak in a little bit of 13.5. Okay, so any questions about anything, please? Let me check the chat. I don't see anything, so we'll go ahead and get started. Okay, and again, I'm always available during my office hours, as you know. Take advantage of Mackenzie and Star's, extra sessions. That's what they're there for. They're there to help you, and I'm here to help you also. And if I have some time at the end, I'll let you ask questions even today in preparation for the test. Okay, that's probably going to be true for all the days from here on out. Okay, so let's continue back with the rational root theorem. Okay, so I introduced it last time. So the highlights of the rational root theorem, page 945. So if you have a polynomial with integer coefficients, okay, then any rational root has to be factor of the constant term divided by factor of the leading coefficient. Okay, you just look at the first term and the last term. The numerator has to be a factor of the constant A0. The denominator has to be a factor of the leading coefficient. Okay, so we did that yesterday. And now stuff like 11, 13, and 15. Okay, 11 and 13 are very reasonable to do. 15 is actually unreasonable to do the whole thing. I'll start some of it. Okay, so maybe I'll just say right now, question 15, I will not ask you a question like that in a test. It's too long. Okay, or I might just ask you to verify, maybe 4 of the solutions that don't work. Okay, show that the given equation has no rational roots. So 11, 13, and 15. I'll do all of 11 and all of 13. They're very easy, but 15 is too long. So 11. So 13.4, page 951. X cubed minus 3x plus 1 equals 0. Okay. this is actually very reasonable to do. It says, show that there are no rational roots. Now we know for sure that there are 3 roots. Whoops, where'd it go? No rational roots, number 11. We know for sure that there's 3 roots because it's 3rd degree. None of them turn out to be rational though. So how do we know that? So the possible rational roots, okay, so rational roots plus or minus factor of 1 divided by factor of 1. Right? From yesterday, has to be a factor of the constant, factor of 1, factor of the leading coefficient, which is 1. Well, what are the factors of 1? 1. Same thing for the bottom. So the only things to try are plus or minus 1. And by the way, that's always going to be the case, right? You know, 1's always going to be a factor of any integer, and same thing here. So you always have a possibility of plus or minus 1. So in this case, show that 1 doesn't work, show that negative 1 doesn't work, and we're finished. Okay, so synthetic division is probably the easiest. X cubed, no x squared, minus 3x plus 1. So 1, 0, negative 3, 1. Is that right? X cubed plus 0x squared minus 3x plus 1. And we'll try 1. Okay. I'm anticipating that this number here is not a 0. There's going to be a remainder, which means that 1 would not be a root. Okay, so 1 times 1 is 1, add, multiply, add, multiply, add. Okay, I don't get a 0. So f of 1 is not 0. Well, yeah, you could just plug in 1 minus 3 plus 1. Doesn't give me 0. And then I'll try negative 1. 1, 0, negative 3, 1. Okay, 1. Multiply, negative 1, add, multiply, add, multiply, add. I got 3. I'm supposed to get 0, so I'm finished. Okay, there are no rational roots. Now we know there are 3 roots. There aren't any rationals. Okay, now when you get to calculus, you'll learn techniques to find approximations for the irrational roots. Okay, but for now, this is all we can do. There are no rational roots. The only things for me to try are 1 and negative 1. They both don't work. So that's it, no rational roots. Okay, so that's very easy. That would be a very reasonable kind of question on an exam. 13 is very much similarly easy because the only things to try again are 1 and negative 1. So look at 13, x cubed plus x squared minus x plus 1 equals 0. The leading coefficient is 1, the constant is 1. So again, there's really nothing else to try. So x cubed plus x squared minus x plus 1 equals 0. 1, 1, negative 1, 1. Okay, so I'm going to try. So once again, the only rationals, let's see, only rational candidates are plus or minus 1. The only rational candidates. Okay. So the rational roots or the rational candidates have to be from this list, plus or minus 1 for the numerator, plus or minus 1 for the denominator, so just plus or minus 1. Okay, so we'll just try it. 1, multiply, add, multiply, add, multiply, add. I got 2. I'm supposed to get 0. So it doesn't work. So I'll try negative 1. So that doesn't work. 1, 1, negative 1, 1. One comes down, multiply, add, multiply, add, multiply, add. 1 doesn't work, negative 1 doesn't work. What do you mean by works? I got to end it with a 0 here. So once again, no rational roots. Okay. Okay, now for one where, again, I would not have you do the whole thing because it's just going to be too long. 15, 12x to the 4th minus x squared minus 6 equals 0. That's going to be no fun. Now, I might ask you to list the possibilities for rational roots like 5, 7, and 9, and then maybe ask you to verify that maybe 4 of them don't work. But to try all of them is just going to take too long. (12x to the 4th minus x squared minus 6 equals 0). This one was easy. All you need to try was plus or minus 1. This one was easy, plus or minus 1. This one is not going to be fun. There's a lot of possibilities. Okay, so the rational candidates or the possible rational roots, plus or minus factor of 6. You don't have to say negative 6 because we're already doing plus or minus. Divided by a factor of 12. That's going to be a long list, I think. Right? Okay, what are the factors of 6? 1, 2, 3, and 6. Right? What are the factors of 12? 1, 2, 3, 4, 6, 12. That is a super long list, right? Take everything here, divided by everything here. So these 4 divided by 1, 2, 3, 4, 6, 12. 4 times 6 is 24, double it, 48. So if I were to do this thing to its completion, I'd have to try 48 numbers. There's no way I'm going to make you do 48 numbers. Well, actually, I take it back because some of these are duplicated. We shall see. Okay, so here we are. Plus or minus, divide each of these by 1. So plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6. Okay, divide all of these by 2. 1 over 2, plus or minus 2 over 2, plus or minus 3 over 2, plus or minus 6 over 2. Right? So you go 1, 2, 3, 6 divided by 1. Here it is. 1, 2, 3, 6 divided by 2. 1, 2, 3, 6 divided by 3. 1, 2, 3, 6 divided by 4, and so on. Okay, now we have some duplicates. 2 divided by 2 is 1, so cross that out. 6 divided by 2 is 3, so cross that out, right? Okay, now divide them all by 3. Plus or minus 1/3, plus or minus 2/3, plus or minus 3/3, plus or minus 6/3. Again, we have duplicates. That's new, that's new. 3/3 is 1, so that's already on my list. 6 over 3 is 2, that's already on my list, so that's out. Okay, then divide all of these by 4. So 1, 2, 3, 6 divided by 4. So 1/4, 2/4, 3/4, 6/4. See, 1/4 is new. 2/4 is the same as a half. That's already on my list. 3/4 is new. 6/4 is the same as 3/2. That's already on my list. So we don't have that many after all. But we still have a lot, but not 24 times 2. Okay, now divide them all by 6. 1, 2, 3, 6 divided by 6. Plus or minus 1/6, plus or minus 2/6, plus or minus 3/6, plus or minus 6/6. 1/6 is new. 2/6 is the same as 1/3. That's already on my list. 3/6 reduces to 1/2, already there. 6/6 is 1, already there. Okay, so we get to cross off a lot just because of the duplicates. And finally, 1, 2, 3, 6 divided by 12. So plus or minus 1/12, 2/12, 3/12, 6/12. Okay, 1/12 is new. 2/12 reduces to 1/6. There it is. What's 3/12? 1/4. There it is. What is 6/12? 1/2. There it is. Okay, so we only, quote unquote, have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 times 2, 22 to try. So we cross out at least half of them. Okay. So if you were to do this problem in its entirety, you'd have to check all of these. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 22. Okay, suppose I should say verify 4 of them. Okay, so I'll just do 4 of them. How about I just pick nice integers? I should pick some positives or negatives. Okay, x to the 4th plus 0x cubed minus x squared plus 0x minus 6. So that's going to be 12, 0, -1, 0, -6. Sorry, I can't show you at the same time. 12x to the 4th, 0x cubed minus 1x squared plus 0x minus 6. Okay, just pick 4 numbers and show those 4 don't work. So let me not pick 1. That's too easy. I've done too many ones. How about 2, 3, and 6 plus or minus? I'll do a couple of those, right? Okay, 2. Now remember, I'm anticipating none of these will end up with a 0 in the remainder. Okay, 12. Multiply, add, multiply, add, multiply, add. You see the numbers getting real big. Multiply 188, 182. Okay, so it definitely doesn't work. Okay, and how about I pick -3? 12, 0, -1, 0, -6. It's not supposed to work. Let's check. 12. Okay, multiply, add, and so on, right? -36, -36. 108, 107. Okay, this is going to get real big, right? So what, -321, -321, 963, 957. Okay, so that doesn't work. Okay, and yeah, let me try one of these fractions for you to show you how a fraction works. It's a little bit clumsy, of course. Oh, how about I pick -1/2? 12, 0, -1, 0, -6. Remember, I'm anticipating I do not get a 0 here. If you get a 0, then you have a solution and a factor. Okay, 12. Multiply, add, multiply, add, multiply, add, multiply. Okay, well, you don't get a 0, whatever that is, negative 5.5. Okay. And maybe I'll pick one more fraction, how about 1/3, and I'll show that doesn't work, and that's enough, right? So rather than showing all 22 don't work, I might just say show 4 of them don't work, I guess. So how about I pick 1/3? Again, I'm anticipating it doesn't work. Okay. Same polynomial. So 12x to the 4th plus 0x cubed minus x squared plus 0x minus 6. 12. Multiply, add, multiply, and yeah, I'm getting stuck with these bad fractions, I guess. 4/3. Negative 1 plus 4/3 is 1/3. Multiply, add, multiply. 1/3 times 1/9 is 1/27. Okay, we don't care. It's not 0. The main thing is it's not 0. Okay, so there we go. So that was clearly a bad problem to do all the way. Okay, so now the rest of the problems in this section, 17 to 27. Factor completely, find irrational roots, solve the equation. Use the rational root theorem. Never mind about the upper and lower bounds theorem. I'm deciding to skip that. Okay, your quiz on Thursday will be just like that. Factor completely, find all the zeros. Big difference. Last time and last week's quiz, you were given one solution. So you know right away what to try. This time you're not given anything. So you have to guess or do the rational zeros theorem, right? So here we go. So factor completely and find the zeros. X cubed plus 3x squared minus x minus 3 equals 0. Okay, factor completely, find all the zeros. Now, sometimes you cannot find all the zeros, like this one. It turned out to be impossible. There's no rational roots. Okay, so in calculus, you'll learn some other techniques, but we don't know what they are right now. So let's look at the possible rational roots. If there are any rational roots, they have to come from what? Factor of 3 divided by factor of the leading coefficient 1. Well, what are the factors of 3? 1 and 3. What are the factors of 1? 1. So the only things I try are plus or minus 1 and plus or minus 3. That's all I have to try. In fact, once I get one of the roots, I'll be down to second degree. Okay. Once you get down to second degree, you breathe a sigh of relief and say, okay, I can use the quadratic formula. Right? So that's always going to work. Okay, so let's try 1. And by the way, remember, you can plug in directly. It's easy to do arithmetic sometimes with 1. 1 cubed is 1. 1 squared is 1. 1 plus 3 is 4. Minus 1 minus 3. Okay, 1 works. I know for sure 1 works. I plugged it in. So when I do synthetic division with 1, right, by the remainder theorem, I should get 0. I've got second degree, then I'm good. Okay, so 1, 1, 3, negative 1, negative 3. So I'm going to go out on a limb and immediately put a 0 here. Because I know when I plugged in 1, 1 plus 3 is 4, minus 1 minus 3, I'm back to 0. Okay, so Synthetic division, 1. Multiply, add, multiply, add, multiply, add. Got it. Which means my original polynomial, p of x. Okay, how do I read this as a factor? If 1 is a root, the factor is, careful, it's not x plus 1, x minus 1. And then how do I read this? X squared plus 4x plus 3. And now I'm good. In fact, I can tell right away this is factorable, right? So remember, if 1 is a root, the factor is x minus 1. Double check. When you plug in 1, do you get 0? Yes, you do. If I had put x plus 1 here, then when I plug in 1, I don't get a 0, right? But now I do. And we can factor that very easily. X minus 1, x plus 1, x plus 3. Okay, so this original is completely factored. Here's the factorization. And the zeros are 1, -1, and -3. All of multiplicity 1. Okay, if the multiplicity is 1, then you don't have to say so. Okay, only if it's a multiplicity 2 or higher, then go ahead and say it. Okay, so the fundamental theorem of algebra said it's third degree. There has to be 3 solutions. Here they are. And there has to be 3 factors. Here they are. You say, what about this one that I got stuck? There's going to be 4 factors. We just can't find it. There's going to be 4 zeros. We just can't find it with the techniques that we have right now. So they're probably going to be irrational or maybe imaginary. Okay. So there we go. Okay, 21. (9x cubed plus 18x squared plus 11x plus 2 equals 0. All right, this looks like it might be no fun. So the possible rational roots, or you can say the only possible candidates, same thing. Only rational the only rational candidates, plus or minus factor of 2 divided by factor of 9. All right, what are the factors of 2? 1 and 2. What are the factors of 9? 1, 3, 9. So how do I write my list? Take everything in the numerator divided by everything in the denominator. So in other words, you go 1 over 1, 3, and 9. And then you go 2 over 1, 3, and 9. So plus or minus 1, plus or minus 1/3, plus or minus 1/9. And then 2 divided by all of these. Plus or minus 2 over 1, plus or minus 2/3, plus or minus 2/9. That is a humongous list. 1, 2, 3, 4, 5, 6 times 2, plus or minus 12. 12 things to try. However, you can get some hints as to what's going on here. For this particular problem, just for this problem, here's something I noticed. See how all the coefficients are positive, right? 9, 18, 11, 2. I definitely cannot plug in any positive number to get it to work. I'm immediately going to cross off all the positives. Can you see why? If I plug in a positive, here, 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 a positive cubed is positive, positive squared is positive, That's a positive. 9's positive. 18's positive. 11's positive. Add positive to positive, you get positive. You're not going to get 0. Okay, so one more time. You cannot have any positive solution, right? Think about it. Plug in any positive number. This expression here is going to be positive. I plug in a positive. If you cube it, it's positive. If you square it, it's positive. That's positive. 9, 18, 11, and 2 are all positive. Positive times positive is positive. Positive plus positive, positive. You're not going to get 0. So I got it down to just 6. Okay. It's nicer, but let's try, well, you're never wrong in trying -1. That's the first nice thing to try. Okay. Now you can either plug it in directly. It's a little bit tricky because of the negatives, or just do synthetic division. Okay, let's just do synthetic division. 9, 18, 11, 2, -1. 9. Multiply. Add. Multiply. Add. Multiply. Add. We got it. -1 works. Right? So now what's my P of X, my original polynomial? Factors into, okay, the fact that -1 gives me 0 means what's the factor? Careful, is it X minus 1 or X plus 1? X plus 1. Remember, if you plug in -1, you get 0, right? If I plug in -1 and then whatever this is, you get 0. And now how do I read this? 9x squared plus 9x plus 2. And is that factorable? I believe it is, right? Three x, 1, and 2. Is that right? Plus plus. Follow this back out. First, 9x squared. Outer, 6x. Inner, 3x. 6x plus 3x is 9x. Last 2. It works. Completely factored. So my zeros are -1. I think you could do this in your head, right? Set that equal to 0. Subtract 1, divide 3, -1/3. Subtract 2, divide 3, -2/3. All right, so mystery solved. Completely factored the original polynomial, 9x cubed plus 18x squared plus 11x plus 2. Here it is. There's supposed to be 3 zeros. Here they are, -1, -1/3, -2/3. And digging even deeper, these are all rational. Are they on my candidates list? -1 is there. -1/3 is there. -2/3 is there. Yes. Right? So the theorem says if there are any rationals, fractions, okay, they have to be from this list. As you see, they're all from this list. It's not a guarantee that any of these work, but we already know that the positives didn't work, right? I made an argument that you couldn't have any positives, and that's true. We don't have any positives that work, only negatives. Okay, but that doesn't mean the others work either. It turns out 2 9ths didn't work, and 2 didn't work, and 1 9th didn't work either. We don't know ahead of time. Okay, so the rational root theorem says if there are any rational solutions, they have to come from this list. But it doesn't mean that any of those are going to work either. Okay, so that one's a little bit trickier. Okay, 25. Even though it's 4th degree, it should be pretty easy to work out, I think. X to the 4th minus 4x cubed plus 6x squared minus 4x plus 1 equals 0. This one's nice. Can you guess what their possible rational solutions would be? Look at this and look at this. Plus or minus 1, right? I mean, the analysis is just like this one. It's plus or minus factor of 1 divided by plus or minus factor of 1. That's a 1. It could be a negative 1 also. That's a 1, could be a negative 1. So the possible rationals are just plus or minus 1. So what should we try? Should we try 1? One, negative 4, 6, negative 4, 1. One, multiply, add, multiply, add, multiply, add, multiply, add. 1 works. How do I read this? X cubed minus 3x squared plus 3x minus 1. But I'm not going to write it out. I got to factor this again anyway. This used to be x to the 4th. Now it's x cubed. So once I am able to do it one more time, I get it down to x squared and then I'm good. Okay. So again, the only thing that I need to try are 1 and negative 1. Why don't I just try 1 again and see what happens, right? So rather than writing a polynomial down, just do synthetic division on this. So 1, multiply, add, multiply, add, multiply, add. It works again. Second degree. I can either do quadratic formula or factor. Okay. So P of x, I got x minus 1, another x minus 1. And how do I read this? X squared minus 2x plus 1. What is x squared minus 2x plus 1? That's x minus 1 squared. So guess what? This thing factors into x minus 1 to the 4th power. All right, so it's 4th degree. I should have 4 factors. Here it is. X minus 1 to the 4th power. X minus 1 times x minus 1 times x minus 1 times x minus, can't even say it, x minus 1. And the zeros, I'm supposed to have 4 zeros. And if we allow for multiplicity, I have 4, right? Because you say the zeros are 1, 1, 1, and 1. If I factor this out completely, the x minus 1, x minus 1, x minus 1, x minus 1. You say this one gives me a 1, this one gives me a 1, and this one gives me a 1. This, they all give me a 1. So the zeros are 1 of multiplicity 4. And there we go. Okay, I'm done with this side of the paper. In fact, I'm almost done with this section. So let me do my focus job. I'll start the last problem I have for this section, then we'll break. Then after the break, I'll finish that and sneak in a little bit of the next section. And then let you ask questions if you have any in preparation for the next test. On that. Okay. So the last one, now don't get your hopes up too high. It's not that nice. 27. They give us fractions, which is not very nice of them. So what do I do if I have fractions? 27. x cubed minus 17 thirds x squared minus 10 thirds x plus 8 equals 0. All right, so I'm not supposed to have fractions. What should I multiply by to clear out the fractions? 3. 3 times that, 3 times that. Three x cubed minus 17x squared minus 10x plus 24 equals 0. Now we got it. Okay. There's a lot of possibilities, unfortunately. But you'll see it's actually not so bad after all. So this is the possible rationals. Plus or minus factor of 24 divided by factor of 3. That's not nice because there's a lot of ways you can get a factor of 24. What are the factors of 24? 1, 2, 3, 4, 6, 8, 12, 24 divided by 1 or 3. That's a pretty long list. You can probably get rid of some of them though, because of duplicates. So divide all of these by 1. Divide them all by 1, I just write all these, right? Plus or minus 1, plus or minus 2, plus or minus 3, 4, 6, 8, 12, 24, and divide all of them by 3. 1/3, 2/3, 3/3, 4/3, 6/3, 8/3, 12/3, 24/3. 1, 2, 3, 4, 6, 8, 12, 24. Divide them all by 1. 1, 2, 3, 4, 6. Divide them all by 3. But let's see if there's any duplicates. 3 over 3 is 1. That's on my list already. 6 over 3, 2. That's on my list. And 12 over 3, 4. 24 over 3, 8. Really not that fun. However, I noticed something really nice right away. Okay. Try 1. 3 plus 24, 27. Negative 17 minus 10, negative 27. 1's going to work. I'll get it down to second degree. Once you get second degree, quadratic formula, if worse comes to worse. Okay. And it's just about our time to break. So we'll finish this after the break. So after the break, I'll finish this. Then I would be done with the section. And then I'll sneak in a little bit of our last section just to make things a little bit better for us time-wise. And we'll still probably finish early. Okay. All right. So we'll break into our usual 12:10. Okay. Anybody who joined late, please put your name in the chat so I can get you later. Okay, folks, we're going to pick up where we left off. See, Dimitri, I got you for attendance. Anybody else who joined late, go ahead and put your name in the chat so I can get you. Okay, so let's pick up where we were. All right, so we were in the midst of doing number 27. A super long list of numbers to try. Fortunately, it looks like one works. Once I get it down to plugging in one, I'll get a second degree, something with squared, then I can either try to factor or quadratic formula. Okay, so 3, -17, -10, 24. 3, whoops, don't necessarily want to use green for that. 3, -17, -10, 24. It looks like one should work. 3, 3, -14, -14, -24, -24, 0. So write the polynomial. Okay, 1 here means what is the factor? The factor is x minus 1. And how do I read this? 3x squared minus 14x minus 24. Okay, I can try to factor. There's a lot of things to try, 24. Or I can use the quadratic formula and don't even worry about it. Let's use the quadratic formula. It's a nice review for the quadratic formula, and you'll need that in the next section anyway. Okay, so I know I have x equals 1. Okay, set that equal to 0. Negative b is positive 14 plus or minus the square root. B squared, negative 14 quantity squared, use your calculator, 196 minus 4 times a times c over 2a, 2 times 3. Okay, so this is 196 plus whatever this is. Let's see, 72, 288. It's a double negative, isn't it? So that's going to be 484. Square root of 484 is 22, very conveniently. All right. Okay, so 14 minus 22 is negative 8 over 6, which is negative 4/3. 14 plus 22 is 36. 36 over 6 is 6. All right, that leads me to believe if x equals 6 is a solution, then that means x minus 6 is a factor. So p of x is x minus 1. So going back to here, x minus 6 works, and then I can work backwards to get the other. So if that's x, I need 3x. 6 times what number is 24? That's going to be 4. And to get a negative 4/3, I need a positive. Okay. So if I went for factoring, this is what it would have been. I wasn't sure if I was going to work, so but quadratic formula works. Let's double check, FOIL it out. 3x squared plus 4x minus 18x is minus 14x minus 24. It works. Okay, so mystery solved. So the factorization, now I guess technically the original didn't have the 3. So if it doesn't have the 3, then I'll just go the original P of X, I'll just say is the original, is X minus 1, X minus 6, X plus 4/3. If I divide the 3 back out, I multiplied originally by 3, I divide it back out. Okay, and the zeros are 1, 6, and negative 4/3. And the problem solved. Okay, check 1, 6, negative 4/3. Is 1 on my list? Yes. 6 is there, and negative 4/3 is here. Yeah, so they're all there. And that's it. Okay, and let me show you the focus thing. I'm done with this section. And believe it or not, folks, we're down to one last section of our class. So just about there. Just about finished with our class. All right, so I'll introduce just a little bit. Okay, so again, the game plan was to do at least 13.4. I've done that. So I'll sneak in some of 13.5. So I won't go that much longer. And then we'll quit unless anybody has any questions. So if anybody thinks they have any questions about anything, feel free to get ready to bring it up, either unmute yourself or put it in the chat. As I do, again, a tiny bit of 13.5. The little bit that I do today will just make things a little bit easier tomorrow. So 13.5, conjugate roots. Descartes' rule of signs, that's one of those things where I decided not to do it. Okay, it's nice, it's correct, there's nothing mathematically wrong with it. It's just not really needed for calculus. Okay, I already talked a little bit about the conjugate roots theorem that I mentioned before. Let f of x be a polynomial, all of whose coefficients are real numbers. Suppose that a plus bi is a root, then a minus b is also a root. Okay, and that also holds for radicals. So conjugate roots theorem if polynomial has integer coefficients. Okay, if integers, plus or minus 1, plus or minus 2, nice coefficients, no fractions, no decimals, no square roots, all that stuff. Okay. If a plus radical b is a root, then a minus radical b is a root. Conjugate pairs. If a plus bi is a root, then a minus bi is a root. That's a direct result, as we said before, of the quadratic formula, right? If you look at the quadratic formula, again, quadratic formula, x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. So let's say the stuff under here came out to be 7. Then you're going to have blah, blah, blah minus radical 7, and you're going to get blah, blah, blah plus radical 7. If underneath the square root came out to be negative, let's say negative 4, then that would be 2i, right? So you're going to get negative blah, blah, blah minus 2i, negative blah, blah, blah plus 2i, right? So you always have conjugate roots. So that's the basic idea. Okay, and again, I shortened your assignment if you didn't catch it. So yeah, I'm marking this off. 13.5 is quote unquote only 1 in 19 odd. Okay, so skip all this other stuff. It's nice. It's rules about upper and lower bounds, Descartes' rule of signs. You don't need that for calc. So If you don't need it for calc, why should I give it in pre-calc, right? So what's happening this time is they give you a polynomial and they give you one of the roots. You automatically have another root, right? Except they're going to be something involving imaginary numbers or radicals. Okay. So that means we know what to do. So an equation is given, followed by one or more roots of the equation. In each case, determine the remaining roots. Okay. So number one, x squared minus 14x plus 53 equals 0. Seven minus 2i. Okay, you already know that one of the solutions is 7 minus 2i. So automatically by this rule, what does another root have to be? 7 plus 2i. And there's not going to be any more because it's second degree. If it's second degree, that's all I got. I got it. So we're finished. Now, what are the factors? How do you write the factors? Well, remember, you go x minus this and x minus this. Okay, so I'll show you how to do that. So x minus, I should put bracket, parentheses, 7 minus 2i, bracket x minus 7 plus 2i equals 0. Okay, now how do you multiply that back out? I'll show you. So distribute the minus sign. You have x minus 7 plus 2i, x minus 7 minus 2i equals 0, or technically you don't have to write equals 0 anymore. Okay, and I noticed that this is the same as that, and that is the same as that. So that's like a squared minus b squared, right? This is of the nature of a plus b, a minus b. So it's a squared minus b squared. So it's x minus 7 squared minus 4i squared. I squared is -1. So -4 times -1 is a +4. So FOIL this out, x squared minus 14x plus 49 plus 4. And there's my x squared minus 14x plus 53 equals 0. So it checks. Equals 0. And there we go. Okay. Another way you can check it is to actually do the quadratic formula. Let's actually do that. So you have all these built-in double checks. So quadratic formula, x equals -b 14 plus or minus the square root of b squared, -14 squared, 196, minus 4 times a, which is 1, times c, which is 53, over 2 times 1, 14 plus or minus the square root of, so scratch paper, this is 196 minus 4 times 1 times 53 comes out to be 212. You can punch that in your calculator. 196 minus 212 is -16 over 2. Take out the I. 14 plus or minus I radical 16 over 2. Square root of 16 is 4. 14 plus or minus 4i divided by 2. Divide by 2. 7 plus or minus 2i. 7 plus or minus 2i. Yep, we got it. Perfect. Okay, so that's what's happening. Okay, now what about all the rest of them? Okay, so I'll set you up with 3, and I was pretty much going to stop after that. Okay, so I'll be done in probably within 5 minutes, in which case, if anybody has any question, feel free to ask it. If not, we're done. Okay, 3. 5 plus 2i. 5 plus 2i means we automatically have 5 minus 2i. X cubed minus 13x squared plus 59x minus 87 equals 0. 5 plus 2i. This one's going to be a little bit tougher. All right, you know the other one is 5 minus 2i. And there's going to be one more after that. Okay, the hard part is, what do you do after this? Okay, so in order to do that, I'm going to have to write out what that polynomial is and do the polynomial long division after that. Okay, so I know 2 of the factors are x minus 5 plus 2i and x minus 5 minus 2i. All right, if these are 2 solutions, then you go x minus each one. If that bothers you, think of x equals 3. X equals 3 means you put x minus 3, right? So no matter how complicated or easy it is, you go x minus that. So x minus parentheses 5 plus 2i, x minus 5, x minus parentheses 5 minus 2i. Okay, so as usual, distribute x minus 5 minus 2i, x minus 5 plus 2i. And this logic tends to be similar. That's the same as that. That's the same as that. So it's a difference of squares. Again, it's like a minus b, a plus b. So x minus 5 squared minus 4i squared. And we know that means plus 4. So this is x squared minus 10x plus 25 plus 4, which is x squared minus 10x plus 29. Okay, these 2 combine to give me this. If I now divide this out, I should get the next factor. Unfortunately, I cannot do this by synthetic division. Remember, synthetic division, you can only divide out linear factors. So the only thing to do is long division. Okay, fortunately, it shouldn't be that bad in this particular case. This is x squared, this is x cubed. So it's just going to be a little bit of division. Okay, so again, synthetic division can only be done if you have linear factors. This is not linear, so we just have to do the whole thing. X squared minus 10x plus 29. X cubed minus 13x squared plus 59x minus 87. And I'm anticipating that we have no remainder. Okay, x squared into x cubed, x. Now multiply this whole thing out. X cubed, x squared times x is x cubed. Negative 10x times x is minus 10x squared. 29 times x is 29x. Subtract. Cancels out. Negative 13 minus a minus 10. 59 minus 29 is a plus 30x. Bring down to negative 87. And this thing into this thing, negative 3. Negative 3 times this whole thing, negative 3 times x squared, negative 3x squared. Negative 3 times negative 10x is a positive 30x. Negative 3 times 29 is a negative 87. Perfect. I know anything that was a funny looking line, but I'm done. If I subtract, I get 0. So the last factor is x minus 3. Okay, so we've completely broken down the original problem. Okay, so it's 3rd degree. There should be 3 factors and 3 roots. Here are the 3 factors. So I just have to rewrite this mess. X minus 5 minus 2i, x minus 5 plus 2i. Those are the not nice ones, and the nice one is x minus 3. And then the zeros. The zeros we had were 5 plus or minus 2i and 3. So we're finished. So again, fundamental theorem of algebra, third degree, 3 factors. Here they are, 3 zeros. Here they are, 5 plus or minus 2i, 3. And then when we say so many zeros, we're allowing for multiplicity, right? There's that other problem we did before the break, right? Fourth degree, there are 4 zeros if you allow for multiplicity, right? They all came out to be 1. So the language we would say is the zeros are 1. The only real solution is 1, but that showed up 4 times, multiplicity of 4. Okay. So that's it. That's my introduction to the last section. I'll finish it tomorrow. Let me do my focusing thing for the rest of this page. And if anybody has any question, go ahead and put it in the chat. Otherwise, we're done for today, folks. And tomorrow, I'll finish up most of the last section. If I don't finish it, I can sneak it into Thursday. Then Thursday, you can start asking questions about the test, and maybe tomorrow also. And then I'll give you your last quiz on Thursday. And then our test 6 is on Monday. So there is that. Okay. All right, so I've already shown you some of these. I'll do most of the rest tomorrow. And if not, I still have Thursday for that. Okay, so let me check the chat. Anybody else with a question? Anybody else for attendance? Okay, Victor, I see you. Got you for attendance. Anybody else missed attendance? Get you now. Go ahead and put it in the chat. Okay. Any other questions at all? Otherwise, we're done. Wait just a moment in case anybody's typing. All right, I guess that's about it, folks. All right, so have a good afternoon and we'll see you tomorrow. All right, have a good day, everybody. Bye.